Hey, my name is Bryce Hellman, and in this video podcast, I'm going to talk about the most abundant resource in the world and how it plays an interesting part in the world of physics. In fact, it's not only the most abundant resource in the world, it's actually the most abundant resource in the human body. And guess what it is? The answer is water. In fact, 55 to 78% of the human body is made of water. It is not just the most commonly found resource, but is also essential for life. Water also has some interesting properties, which makes it a good resource to use for some common everyday tasks that we normally take for granted. And we all know that water molecules is H2O, which is 2 hydrogen atoms and 1 oxygen atom. But most don't know why this combination is the key. Unlike a covalently bonded molecule, which means the atoms in the molecules are actually sharing electrons, H2O is created by means of a hydrogen bond. For the most part, when hydrogen is involved, it is responsible for holding things together inside of a molecule. The interesting thing is, though, is hydrogen bonds are classified as a weak ionic bond. Now, ionic bonds are molecular bonds that hold atoms together by means of a charge rather than by sharing electrons, which is a covalent bond. As the oppositely charged particles come in contact, they are held together magnetically. This is why droplets of water stick together to make bigger droplets when they come in contact. They are actually magnetically attracted. And my first experiment is to demonstrate the magnetic forces involved when it comes in contact with water. We are all familiar with static electricity, right? It's that annoying shock you get when you touch something metal. Now the reason for that is due to electrons moving from the carpet to you due to friction. In the same way, I can build an electric charge on a balloon by using friction. Now watch what happens when the charged balloon comes close to a small stream of water. The negative charge of the electrons on the balloon attract the positively charged water molecules. Now while this is just a neat trick, it also does play a very important role in everyday life. You can actually appreciate magnetism the next time you go to wash your hands. It is the magnetic properties of water that make soap work. Chemicals in soap fill into the pores in your hands, attaching to dirt physically. As water comes in contact with the soap magnetically adheres to the water and simply washes away. That's why your hands feel sticky when you're putting soap on. It gets harder to massage in your hand, and the water just washes right away nice and easily. We know that we can break substances down through a reaction. Usually that reaction is by means of heat or fire, but water doesn't burn. So what other way can we create a reaction? Contrary to popular belief, water is actually an insulator, meaning it conducts electricity very poorly. It is actually the impurities in the water that create an electrical bridge. Now, as I mentioned earlier, H2O is formed by a hydrogen bond, which is classified as an ionic bond. This means that an electrical current is enough to break the bond. Through a process called electrolysis, a current is introduced in a solution of water and usually Epsom salt to create the electric bridge. Notice that each electrode of opposite poles are under a separate test tube. The reason for this is that oxygen and hydrogen have different charges after they are separated. Hydrogen has a slight positive charge and oxygen has a negative charge. Since the polar opposite electrodes are separated in their own test tubes, the atom particles will be attracted to the test tube with an opposite charge. When the water is depleted, the test tube above the negative electrode will contain pure hydrogen, while the positive side will contain pure oxygen. Now here's a live action shot of the electrolysis process. Notice the massive amounts of bubbles around the electrodes. You can also see that there are twice as many bubbles around the negative pole as there is around the positive pole. I hope that by viewing this podcast, you learned something new and might appreciate water just a little bit more. That is the world of physics as it relates to water and magnetism. Thanks for watching.